Now, with each development in the field of AI, fears regarding the dangerous potential of artificial intelligence seem to be on the rise.
Imagine a world where machines can think, learn, and act like humans, where technology can solve our biggest problems and create new opportunities. Let's find out more. Artificial intelligence is the ability of machines to perform tasks that normally require human intelligence, such as understanding language, recognizing images, solving problems, and learning from data. AI is transforming the world in many ways, and it will have a huge impact on various sectors, functions, and aspects of society in the next 10 years. Neurotechnology is a fascinating field that combines neuroscience and technology. It's all about understanding our brain and nervous system and using this knowledge to create technologies that can help us in various ways. When it comes to learning, neurotechnology has the potential to make a big impact. Imagine a world where learning is not just about reading books or listening to lectures, but also about using technology to tap into the power of our brains. This is what neurotechnology for enhanced learning is all about. It's about using technology to understand how our brains work when we learn, and then using this understanding to create tools and techniques that can help us learn more effectively. So how does neurotechnology work? Well, it involves using neural interfaces to read or write information into our nervous system. These interfaces can be used to gather information about how our brain works when we learn, or they can be used to influence our brain and nervous system to enhance our learning abilities. 3 main types of neurotechnologies are relevant to learning. Neuromodulation technologies. These technologies use neural interfaces to stimulate our nervous system and influence its activity. For example, they can be used to reduce tremors in Parkinson's disease or to treat chronic pain. In the context of learning, they can be used to improve neural activity associated with learning and memory. Neuroprosthesis. These are devices that replace or restore functions that we have lost. A common example is the cochlear implant, which restores hearing in people with profound hearing loss. In the context of learning, neuroprosthesis could potentially be used to restore cognitive functions, brain-machine interfaces. These technologies read and write information into the brain, enabling us to control external software or hardware. For example, a BMI could enable a person to control a robotic device using their thoughts. In the context of learning, BMIs could potentially be used to enhance our ability to interact with learning materials. Neurotechnology for enhanced learning is not just about creating new technologies, but also about understanding how our brains work when we learn. By studying the neural mechanisms underlying learning, we can gain insights that can help us develop more effective learning strategies and tools. For example, research in neuroscience has shown that our attention span, memory systems, and emotions all play a crucial role in learning. By understanding these aspects of our brain function, we can develop neurotechnologies that take advantage of our natural attention span, use our memory systems more effectively, and harness the power of our emotions to enhance learning. Neurotechnology for enhanced learning is a promising field that has the potential to revolutionize the way we learn. By combining our understanding of the brain with the power of technology, we can create tools and techniques that can help us learn more effectively and efficiently. This is not just about improving education, but also about empowering individuals to reach their full potential. Bioprinting is a revolutionary technology that's changing the way we think about organ creation. It's a process that uses 3D printing technology to create living tissues, and it's opening up new possibilities in the field of medicine. At its core, bioprinting is about creating something living from a digital design. It's similar to how a regular 3D printer works, but instead of using plastic or metal, a bioprinter uses cells. These cells are often suspended in a gel-like substance that provides support and nutrients, and they are carefully arranged layer by layer to form the desired tissue. The process starts with a digital model of the organ that needs to be created. This model is usually created using medical imaging techniques like MRI or CT scans. The bioprinter then uses this model as a guide to deposit the cells in the right places. One of the key challenges in bioprinting is ensuring that the printed tissue is viable and functional. This means that the cells need to be able to survive the printing process, and they need to be able to function together as a tissue once they are printed. To achieve this, researchers are developing special bioinks that can support cell growth and function. Bioprinting has the potential to revolutionize organ transplantation. Today, many people who need a new organ have to wait for a suitable donor. However, with bioprinting, it might be possible to create a new organ in the lab using a patient's cells. This could eliminate the need for donors and reduce the risk of the body rejecting the new organ. However, we are still a long way from being able to print complex organs like the heart or liver. These organs have intricate structures and they are made up of many different types of cells. Bioprinting something this complex is a huge challenge, and researchers are still figuring out how to do it. In the meantime, bioprinting is being used to create simpler tissues like skin, cartilage, and blood vessels. These tissues are already being used in research, and in some cases, they are even being used to treat patients. Bioprinted cartilage could be used to treat conditions like arthritis. Instead of replacing a damaged joint with a metal or plastic implant, doctors could implant a bioprinted cartilage that can grow and integrate with the patient's tissues. Advanced robotics is a fascinating field that's all about creating robots with high levels of intelligence and autonomy. These robots are not just machines that follow orders. They are capable of understanding their environment and making decisions based on what they perceive. At the heart of advanced robotics is the idea of creating robots that can do more than just perform simple, repetitive tasks. These robots are designed to handle complex tasks, adapt to changing conditions, and even learn from their experiences. One of the key features of advanced robotics is the use of sensors and sophisticated software. These allow the robot to perceive its environment, process the information, and make decisions. For example, a robot might use cameras and other sensors to detect obstacles in its path and then use its software to decide the best way to navigate around them. Another important aspect of advanced robotics is the ability to integrate with other systems. This means that the robot can work in harmony with other machines and systems, and even with humans. This is particularly important in industrial settings, where robots often need to work alongside human workers. Advanced robotics also involves a high degree of adaptability. This means that the robot can adjust its behavior based on changes in its environment or task. For example, a robot might adjust its speed or route if it detects an obstacle in its path. Finally, advanced robotics involves a high level of mobility. This means that the robot can move around in its environment rather than being fixed in one place. Advanced robotics is already having a big impact in areas like manufacturing, where robots are used to automate complex tasks and improve efficiency. But the potential applications of advanced robotics are vast, and we are only just beginning to scratch the surface. In the future, we can expect to see advanced robots being used in a wide range of settings, from healthcare to agriculture to space exploration. These robots will not only be able to perform tasks more efficiently and safely than humans, but they will also be able to do things that humans simply can't do. Quantum computing is a rapidly emerging technology that leverages the principles of quantum mechanics to solve complex problems. Unlike classical computers that use bits, zeros, and ones for processing information, quantum computers use quantum bits or qubits. A qubit can exist in a superposition of states, meaning it can be in both states, 0 and 1, simultaneously, which allows quantum computers to process a vast number of computations at once. The fundamental unit of quantum computing is the qubit. Just like a bit in classical computing, a qubit can represent a 0 or a 1. However, due to the principles of quantum mechanics, a qubit can also represent any quantum superposition of these states. This means that a quantum computer with several qubits can represent and process a vast amount of data simultaneously. Quantum computers have the potential to solve certain problems much faster than classical computers. For example, they could potentially crack encryption codes that would take classical computers thousands of years to solve. They could also be used for complex simulations in physics and chemistry that are currently beyond the reach of our classical computers. However, building a practical quantum computer is a huge challenge. Qubits are extremely delicate and can be easily disturbed by their environment, a problem known as quantum decoherence. Researchers are working on developing qubits that are more stable and less prone to errors. Artificial intelligence is changing the world as we know it. Our values, our humanity. Comment your thoughts on this and don't forget to like, share and subscribe.